Eighth graders, you need to be quiet. We're moving to an extension of Pythagorean theorem. All Chromebooks should be shut. And one of the extensions to Pythagorean theorem is simplifying radicals. That means that I'm going to give you something like this, the square root of 200, and without using a calculator, you're going to break this down and realize that it is 10 root 2. You're going to be able to do that today. So it looks much fancier than a decimal, and that's what you're going to see a lot in 9th grade as well. So we're going to connect it to Pythagorean theorem because Pythagorean theorem is always with square roots. Something very, very important that you need to remember. The square root of a number, can you put squared? I forgot to do that. The square root of a number squared will always be the number inside. So the square root of a number squared is always going to be the number inside. It cancels out the root. And I want to just show you, like the square root of 4 squared is square root 4 times square root 4. Which you can evaluate the square root of 4. The square root of 4 is 2. This really turns into 2 times 2, which is 4. That just shows you that when you square a square root, it cancels out. It's just the number itself. I don't know if you saw, I have it somewhere. Maybe it's on front of my door, but it's this really cute math quote. Look at it. It goes this. I square root heart squared math. That means that I square rooted or I squared a square root. It canceled out the square root, and it means I love math. Isn't that cute? So that's so cute.
But just put I heard math.
Because it doesn't have math symbols. Okay, the square root of 25 squared. If you have the 2 square roots, it's going to cancel out. It's going to just turn to 25. But before you guys, I always show kids why that is before I just expect that you can apply it. So this would be root 25. And you're going to see that I kind of go between square root and root. It's the same thing. Times the square root of 25. That's 5 times 5, which turns to 25. Again, telling you if you have 2 square roots, or if you square a square root, it cancels out the root. It's the inverse. It's doing the opposite. Like the opposite of squaring is to square root. The opposite of square root is to square. Okay, so here we go. We're going to simplify radicals. The first thing you're going to do is find the perfect square that goes into it, or use a factor tree. I want you to write your perfect squares down. Let's do the first 15. Ready? We're going to go 1, 2, 3, 4, 5, 6, 7. I'm going to go up here. 8, 9, 10, 11. Write this down. 12, 13, 14. Oh, no, I said 15. And then I'll just put 15 right here. Okay. So you're going to want to be able, you can use a calculator to identify what perfect square goes into the given square root that I give you. Because there's a lot of times I'm not going to know the perfect square. So I have to try to divide into it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 100, 11 squared 121, 12 squared 144, 13 squared 169. I don't know 14. I know 15 is 225.
14 is 196.
14, 196. Okay. Those are the most common ones usually. Sometimes you get 20 in there. 20 squared is just 400. But these are the most common ones. So I want you to make sure to have them. And we will be taking a mini quiz on this at some point next week. I want you two to switch spots. Okay, then you're going product inside. Now you guys don't know how to do this, so I don't want you to just assume and act like you don't need to pay attention like a lot of you are doing. Watch. You're going to find your perfect square. You're going to rewrite it. And then you're going to, anything that's left is going to go inside the square root. Here I go. The square root of 200. Which perfect square goes into the square root of 200?
10.
So 100 or 10. That's what. So you can turn this into, go like this. Go like this. Make a factor tree kind of. Turn this into the square root of 100 times the square root of 2. Do you see that? I took my square root and I'm just breaking it down because I want to find its perfect square that's inside it. So I broke it down, and then, because really you can just multiply things in here. You can turn it into a different multiplication. So now the square root of 100 is that perfect 10, and then anything left goes inside the square root. So it would be square root 2. And that is the answer you will write down, 10 root 2.
No chance.
Okay, good thing I have more examples. When I look at 50, step 1, I find the perfect square that goes into it.
5.
So, yep, 25 goes into it. So you can turn this, maybe you like to see it like this. Make a big square root. So that could be 25 times 2. Do you see where that came from? I broke my 50 up into the square root of 25 times 2. Because 25 is a perfect square. What's the square root of 25? 5. So I can take this out and just turn it to a 5. And what do you have left?
2.
2 in the square root. So 5 root 2.
That must be easy.
And you can check your work with your calculator. If you go 5 times the square root of 2 or in the square root of 50, they'll be the same thing. That's how you can tell if you did it right. The square root of 80. So I'm not really sure. It's got to be not that. It's maybe just
1.
no way 49 goes into it. 36. I'm going to try 36. So I'm going to go 80 divided by 36. Nope. I'm going to try, no, it's not 25. I'm going to try 16. So 80 divided by 16 is 5. So the perfect square of 16 goes in here. So this is really the square root of 16 times 5. Now I have my perfect square. And when I have my perfect square, I can evaluate that. What's the square root of 14? Or 16? What's the square root of 16?
27.
4. What? Yeah, I know. Don't be random. Okay, now let's be non-random. The square root of 16 is 4. So that gets rid of that number, and then you can't simplify root 5 down. So it would be 4 root 5. That is beautiful math right there. You look so fancy doing this stuff. Okay, let me add one extension to this.
No.
There might be a number that sticks to the root, okay? So if a number sticks to it, like this, if I had 5 times the square root of 200, I'd need to simplify this. And then this just means at the end times by 5. Anytime something sticks to some kind of operation, it means multiply. That's what it means. It's just like if I had this, 5 times 7. That means multiply. They're sticking together. So this, I'll show you. So first you simplify the square root, and then you multiply by the number that's sticking to it, okay? And sometimes don't forget, because sometimes I accidentally forget. So my square root of 44, heck if I know. I gotta do some perfect squares. I'm gonna try 16 again. For some reason, 16 is hanging out in my head. So I'm gonna go 84 divided by 16. No, that's not it. What's another perfect square?
1.
No, you never use 1.
2.
12 squared is 144. There's no way. Okay, so I'm gonna try. It wasn't 16. It's not 9. I wonder 4. 84 divided by 4 is 21. Yep, it's 4. So 3 square root 4 times 21. Okay? And that's me using my calc. I used my calc to find the perfect square that went into it. Okay, so now my perfect square is the 4. So what's the square root of 4? 2. So now this means multiply. So it's going to be 3 times my perfect square, 2. And then the 21 stays inside the square root. Because there's not a perfect square that goes inside it. 3 times 2, 6, root 21. Okay. Square 9 root 24. 4 goes into it, yep. So it's 9 square root 4 times 6. Okay. And then let's see. 4 is my perfect square. So this turns into a 2, and you multiply it. It's gonna go out and be multiplied with the 9. 9 times 2. Again, you might want to just show, if you're looking at your notes to help you today, you might just want to show that the 2 came from that perfect square inside. Okay, and then the square root of 6 is just left over, root 6. And then you actually multiply. 9 times 2, 18, root 6. Okay, so that is your main learning target today, is that I'm going to give you an irrational number. All of these are irrational, which means it will never be a perfect square, right? I'm going to give you an irrational number, and you're going to break it down. You don't put your notes away because you might need them to see which perfect square to use. Because sometimes those perfect squares, it's hard to know which one to use.